Okay, here's all the information I could possibly squeeze out of the Enhanced Input system. Enhanced Input is the system Unreal Engine uses to translate your real-life button presses into in-game actions. When you press a key, your input goes through several steps before your gameplay code is executed. It starts with physical input, which is like your spacebar, mouse, trigger, joystick, to your input mapping context, which calls an input action, which goes through modifiers, which has triggers, which get called in your blueprint code. Throughout this series, I'm going to be covering every single part of that pipeline, but for now, it's just useful to know the order everything goes in. Enhanced Input is separated into two main classes, Input Actions and Input Mapping Contexts. Input Actions label and define how an input is read, while Input Mapping Contexts assign keys and buttons to those input actions. Input Mapping Contexts are classes so that you can create multiple different presets to use for different things. Maybe one is for walking around, and a different one is for driving around, and another one is for navigating menus, and so on. A lot of projects that you work on, though, will only ever require one mapping context. For example, you might have an input action called jump. The input action itself doesn't care about what physical keys are pressed, it just defines how the input is executed. You then assign it to a mapping context in which you can say, spacebar triggers the jump input action, the bottom face button on a controller triggers the jump input action, or tapping the screen on mobile triggers the jump input action. You get the idea. This separation makes it easier to support multiple input devices and also makes it possible for players to rebind their controls later. Different peripherals have different ways of sending signals. Keys on a keyboard are binary. They're either unpressed or they're pressed. This gives the computer a Boolean value. It's either true or false. Alternatively, a trigger on a controller can be pressed down partially, outputting a value of anything in between 0 and 1 to the computer. Rather than just pressed or unpressed, it could be pressed halfway. A mouse can move in two directions at once, so it gives out an X value and a Y value, outputting a 2D vector. And joysticks on a controller are also 2D vectors. Enhanced Input is designed to handle all of these different kinds of inputs through the same system. Input actions also have different value types, and you can choose what kind of value they output when they're triggered. Remember, mapping context decides which physical inputs trigger an input action, but the peripheral's output doesn't have to match the value type that the input action outputs. And we're going to be doing that later. Before we can start creating inputs, there's one more concept that's worth briefly mentioning. To use a mapping context, we need to register it with one of Enhanced Input subsystems. The local player subsystem is the default, and it's the one you'll use for pretty much everything. Input is designed to flow through a specific player controller and pawn, but there's also the world subsystem, which input isn't tied to any particular player. Instead, actors in the world can register themselves to receive input directly. Epic's documentation recommends that you use the local player subsystem if you're ever making a game that's utilizing the player and player controller classes. And we're going to be using the local player subsystem. One last run through. Physical devices send input. Input mapping contexts decide what physical input should call what input actions. Input actions define the input through modifiers and triggers. Modifiers can change the input value data. Triggers decide when the action should fire, and your blueprint receives the input event last. All right, I'm going to create an input action in my content browser. If you right-click, hover over input, you can choose input action. I'm going to call this tutorial action. And we also need to assign this to a mapping context. So I'm going to right-click, go to input mapping context. I'll call this IMC input tutorial. Now, if you're making multiple, you might have one that says like IMC player walking, IMC player driving, IMC menu, or whatever, but I'm just going to be using the one. Okay, let's open the IMC input tutorial. I'm not opening the actual input action itself. I'm just going to leave all the default values there. And in here, we can open up default key mappings and assign a new mapping. So I hit the plus button, opened up the drop-down menu, and we can select that input that we created, IA tutorial action. Then in the drop-down from that, we can assign keys to be assigned to this input action. I want to assign the spacebar, so I could either click here and search for it, or I could just click on this input listener and then hit spacebar in real life, and that will assign it as well. So now we've told what physical button should call which input action. Now let's get the input action and tell it to do things inside our code. So I have a little player character here that's already set up, but it's got no code on the inside. If I right click, I can now search for IA tutorial action. And you want this one up here with the little arrow, and it creates a new event. Triggered is the pin that will fire once the input action is triggered. So let's try printing a string. And I'll just have it say hello. But it's not going to work because I hit play and I hit spacebar, nothing's happening. And that's because we need to tell the engine that we want to use this mapping context specifically. Remember, you can make multiple, so it doesn't know which one to use by default. So on the begin play, we need to get the enhanced local input player subsystem. It's quite a mouthful. And I'm choosing the one under the category of local player subsystems, not the one under player controller, because this one's more for if you have multiple player controllers, which I don't. From here, we can add that mapping context. So we'll do add mapping context, plug that in, and then we can select which one we want, input tutorial. And that's all that it takes to activate it. If we hit play now, every frame that I hold down spacebar will print a string. You can add as many mapping contexts if you like, and then you can decide which ones have priority over others with this little priority pin right here. Higher number will take priority over lower numbers. Adding mapping contexts also have some options available in a struct. So if we take this out and we do make modify context options, it's just 3 booleans. One is ignore all press keys until released. So imagine you're holding down a key and then you switch from one mapping context to another, and both mapping contexts are using that same key. We'll say spacebar. If this option is enabled, the new mapping context won't consider that key pressed until you release it and press it again. If it's disabled, if we turn that off, it will immediately register that that key is pressed. So there's definitely uses for both of them. I think more often you will want that on. Force immediately is something I would not recommend turning on. When you add or remove a mapping context, it's actually deferred until the next tick, the next frame. And this is done intentionally so that Unreal can safely finish evaluating the current frame's input before changing everything under the hood. You can enable force immediately, which would immediately assign the new mapping context, but it's a bit riskier because it could possibly mess up whatever inputs you're using right at that moment, since it didn't have that frame to clean everything up. Notify user settings is an option by Unreal's built-in user setting system for things like saving keybinds and saving different input profiles, but we're going to go over that way later. Since I left these all at their default, I'm just going to delete it. And now that the mapping context is active, our input action is actually working. Now, I want to note that you can call these events anywhere. If I create a regular actor and open that up, I can also create one right here, IA tutorial action. But it's not going to work in here. See, if we print a different string, print, it won't call this because actors do not register input by default. See, we still only get the hellos. Going off on a bit of a tangent here, but we can allow actors to register input by going to class defaults, searching for input, and auto receive input is set to disabled, but we can set it to player 0 if we wanted this actor to have input. But this is still not going to work because, as I mentioned a little earlier, we're using the enhanced input local player subsystem, which is designed to work through the player and the player controllers, which the actor is not a part of. If you wanted to use inputs on regular actors like this, you would have to use the world input local player subsystem. Or I'm sorry, it's just called world input subsystem or something like that. You would have to go to edit, project settings, engine, come down to enhanced input, and enable world subsystem. It is experimental, which means it's usually not safe for shipping. There still might be bugs and such. So I'm going to delete this, and I'm going to delete this. But my main point was that you can call those events from anywhere, even components, which can't handle collision at all under any circumstances. If I create a component, go to the event graph, I can still call IA tutorial action, but this will never do anything. It'll never call anything from this event. So 3 things to require input to be able to work. 1, a mapping context has to be applied that contains the input action inside of that mapping context. If we're using the enhanced input local player subsystem, which I'm assuming you are, it has to be within a pawn or a player controller or a character, and the actor must be receiving input. One thing I want to note, just because I brought it up a tiny bit ago, if you go to class defaults on our player and search for input, you'll see that the auto receive input is also set to disabled, but when a controller possesses a pawn or a player, it'll automatically change this to 1. So we want to leave that at disabled because if you have multiple characters, you only want the one you're controlling to register input most of the time. And before we move on, I want to talk about another feature that's really useful, which is debug keys. So unlike input actions, debug keys don't require making an input action or a mapping context, but you could just search debug key and get any key you want. Let's try O, and off press and release, this will fire anything you need. I'm a debug, and now if I hit O, we get that string. It's much, much faster if you just need to test something out. But these are purely for debugging. They won't work in a shipped game if you notice this development only tag on both the print string and the key. That means that in a shipped game, none of this will run. Anything with a development only tag will not run. Now, input action events have more pins than just trigger. They have quite a few, actually. If we expand this right here, we have a bunch of options, but I don't think you'll fully understand these without understanding input action triggers first, so we're going to go over those first. And we can navigate right here to the triggers variable. It says 0 array elements because it's an array. So if we add one, and look, we have a few options here. If nothing's applied, which nothing is by default, it uses the down trigger. So having just the down trigger in here is the exact same as having nothing in there. And what that does is trigger every single frame that we're holding down the button. The most common one I change it to is pressed, which will only trigger the first time we press down on the button. So I'm holding the spacebar, but it just says hello once. Released, as you can probably guess, fires off only when we release the key. So I'm holding it down and I'm releasing, and there is our string. You can also stack these since it's an array. So if we have both a pressed and released trigger, it will fire both when I press down on it and we'll wait for the string to go away and then release it. And it triggers both times. So you can create fun combos, create fun and useful combos from these triggers. Okay, let's go over the rest of them. I'm doing them out of order because I'm trying to go from least complex to most complex. That's why but we will cover every single one. So next, let's look at the hold trigger. The hold trigger requires the input to be held for a certain amount of time before it triggers. So you can choose the hold time threshold here, which is how long you have to hold it before it triggers. So we can go ahead and test that out, set to 1 second. So I'm pressing now, and 1 second later it starts to trigger, and it triggers every frame that I'm still holding it down. You can also change that by selecting is one shot here, and then it will only fire once after the 1 second is up. Just like that. Affected by time dilation controls whether changes to the game's timescale affects the hold duration. For example, if the hold time threshold is 1 second, and your game is running at half speed for a slow motion effect, you would enable this if you wanted this to take 2 whole seconds, because it's running half speed, or keep it disabled if you still wanted to take 1 real life second. The actuation threshold is on most of them. I meant to bring it up with the first one. This is if you have a type of physical input that doesn't just output a Boolean like a trigger on a controller, how far that has to be pressed before it counts as pressed for this input. So you would have to put the trigger more than halfway down for this one to count. Or we could say 0.1 if you barely need to tap it, or 1 if it needs to be all the way. Okay, the next one, hold and release. This is essentially the exact same thing, but you have to hold it down for this amount of time, and then it triggers after you release. If you release the key before this amount of time's up, it is canceled. So I'll try it. It's set to half a second. So I'll just tap my spacebar really fast, and we get nothing because I didn't hold it down for half a second. So now I'm going to hold it. That's half a second, and I release, and there we go. There's our string. If we go down to tap at the very bottom here, not repeated tap, tap. This one, we have to press and release the key within this amount of time, 0.2 seconds. So let's give it a shot. I'm going to tap it. Then we get hello, and then I'm going to press and hold for a second and release, and we get no string because it has to be a tap. Repeated tap is similar, but you have to press it a certain amount of times before it's registered as triggered. So let's do repeated tap. We're going to look at these out of order. So the tap to release time threshold is the same as the last one. This is how much time you have between pressing and releasing the key. Number of taps which trigger repeat. This is how many times you have to press it for the input action to be triggered. I'll change it to 3. And repeat delay. This is how much time you have in between taps before the entire combo is canceled. So if I hit play and I hit spacebar 3 times really fast, we get hello. If I take too long between taps, it doesn't work because I waited over half a second in between. And if I hold it down too long, same thing. The pulse trigger repeatedly fires at a fixed interval. By default, it's once every 1 second. You can also choose whether the first pulse happens immediately when the button is pressed, or whether it has to wait until the first interval has passed before it starts counting. So with this checked and at 1 second, actually, I'm going to make it 0.2 seconds because strings only last 2 seconds. And I'll hold it down, and we're getting every 0.2 seconds it's firing. Unchecking that, it would have to wait 0.2 seconds before it fired the first one. Trigger limit is how many times it fires until it doesn't fire anymore. If it's set to 0, it's infinite. We could put it to something like 10, try it out, and it'll stop at 10. I'm still holding the spacebar, but nope, I can't get any more until I release and press it again. Okay, next is corded action. The corded action trigger requires another input action to already be triggered before this one can activate. So to demonstrate, let's create a second input action. It's complaining because I added that, but I didn't set it up. So I'm just going to delete the triggers, open the content browser, right click, go to input, input action, call this IA, secondary action. I'll open IMC input tutorial, add this one as well, and I'm going to make this left shift. Now going back to tutorial action, not our secondary action, let's add a trigger. Let's do chorded action, and the chord action will be our secondary action. So basically, this secondary action has to be triggered for a tutorial action to trigger. So if I hit play and I press space, nothing happens. But if I hold shift and then I hit space, now we're getting print strings. Okay, next is the combo. The combo trigger lets us require a sequence of other input actions. This is similar to what you'd see in like Mortal Kombat when you're doing a fatality, or any fighting game and doing any kind of combo move. So for example, I'll add 3 steps to our combo actions, and I'll make them all secondary action because that's all we have. So 1, 2, 3. And by default, the combo step completion states is on triggered. But in the secondary action, we left this at default, and that's the same as using the down trigger, which fires every frame you hold it. So this combo would be completed in 3 frames because it's triggered once, again, and a 3rd time immediately. So instead, let's change this to pressed. So I actually have to release and press it again 3 times in order for this combo to work. And the time to press key is how much time you have to press after you press the last key. So the first time to press key is pointless. You could even set it to 0 and it would still work. And then all the rest is after I press this button, how much time do I have to press this button? I have half a second. So let's test this out. I'll hit play and I'll hit shift 3 times. And there we go, we get our hello, and that's our combo. If I take too long, it won't work. There's also cancel actions. So if there's any other key you press, it would cancel the entire combo. It's also worth noting that the combo step completion states, you can choose more than one. You can see this is actually more of a checkbox than an actual just choose one deal. And that's every single type of trigger. You're not limited to using a single one. Like I said, you could stack multiple together to create more complex behavior. And one combination I use all the time, probably more often than the default, is I put both pressed and released. Or I don't use this more than the default. I use pressed more than the default of down. But a good combo I like to use is pressed and released. So I think that's the same example I showed last time. I press it and it says hello, and I release it and it says hello. And that's good for any actions where you have to be holding down a button. If you have a hold key for crouch, you could press it to go into crouch and release it to get out of crouch. But how do you know which time it's pressed and which time it's released? If we go back to our player, remember every input action has an output type of either Boolean, float, vector2, or vector3, and we can set that right here under value type. With a Boolean, it just outputs true or false, and since we're using keyboard keys, they are also true or false, so it just outputs whether our key is pressed or if it's not pressed. So if I put the action value into the string, when I press the key, it'll say true, and when I release the key, it'll say false. Okay, so now we understand triggers, which decide when our events get triggered. We can look at the other pins. Triggered is the one you'll be using the most, and you'll be defining how it works with the triggers right here. But there's also started, which is kind of the same as using pressed. It'll only output when it starts. So if I hit spacebar, it only outputs once, and it won't output when I release because it's not checking our triggers. It's just saying this is the first frame where you press down on the button. Ongoing and canceled don't do anything by default, so I'm going to come back to this real quick. And completed is when you release the key. It's the last time that the key is triggered. So I release and it says false. But this isn't always necessarily when you release the key, it's just when the last triggered frame happens. So if I go into our input action, and I already did it to test, if you remove the removed trigger and it's only pressed, that means it only ever fires once. So as soon as I press the spacebar, it will output because it's the last frame that event will fire. Ongoing and canceled are for more specific triggers. If we change it to hold, where we have to hold it for 1 second for it to fire, the ongoing will fire for that entire second leading up to the trigger. If I do this, it'll fire for 1 second, and then it'll start going away. Yep. And canceled is if you release the key before that threshold has been passed. So if I hold it down and it's not an entire second, it outputs canceled. It outputs from the canceled pin. I'm going to be removing all the triggers for a second, so it goes back to its normal pressed every frame style. And we also have elapsed seconds and triggered seconds. Elapsed seconds is how much time has passed since you started pressing the button. So if I hold it down, it'll just start counting up. I release it, it'll go away, and it'll start over when I press it again. Triggered seconds is the same thing, but it starts when the input is triggered rather than when the physical button is pressed. So if we actually put this, I shouldn't have removed it. If we put this hold trigger back, where you have to hold it down for 1 second, and we hit play, and I start pressing it, it'll only start counting up once that second has passed, whereas elapsed seconds will start as soon as we hit the key. We still won't see the print strings at first because this triggered pin isn't being called, but you'll see it starts at 1 second rather than 0 seconds. So that's the difference between those two. The final output is the input action itself. This is just a reference to the action. It lets us inspect information about the input action while the event is running, so we could get the triggers and we could get the modifiers and do all that kind of stuff. And just basically access information about what we've set in the input action, if we were to ever need it. So when I make my projects, I pretty much almost always only use the triggered pin, and I'll just use these in some other rare cases. So let's move on and talk about modifiers. If we open up our input action, we have our triggers here. I'm going to remove that, and I'm going to add a modifier. Instead of deciding when an input action executes, modifiers change the value being passed into it before your blueprint receives it. So most of these actually work a lot better with a value type that isn't a bool. So let's go ahead and make a third input. Oh, it's complaining because I added a modifier, but I didn't assign a modifier to it. So I'm going to right click, input action, and I'm going to call this IA look. And I'll open that. We're going to change the type to an axis 2D. So instead of outputting true or false, it outputs an X value and a Y value. Then in my player character, I will add the IA look. And to control my rotation, I will get the player controller, and I'm going to add yaw input, which turns me left and right, and add pitch input, which makes me look up and down. For left and right, I'm going to break the vector 2, which gives us the X value and the Y value, and I'm going to be controlling this with my mouse, so moving my mouse left and right is the X value, and I want that to turn me left and right, and moving my mouse up and down, I want to make me look up and down. And then in the mapping context, we need to assign our mouse, so let's add one, add IA look, and in here there is a special one called mouse 2D axis, mouse XY 2D axis, so we don't have to put in each axis specifically like we used to. And now if I hit play, I can now look around while I move my mouse. Now the Y feels inverted to me. When I move my mouse up, I look down, and that feels backwards to me. So I'm going to temporarily take my Y and multiply it by -1 to fix it for myself. And now I look around in the way I expect. So let's put some modifiers on this input. So I'm going to close tutorial action and secondary action. I'm going to go into IA look, and let's add a modifier. The first one we have is dead zone, and this is mainly for controllers, for any peripheral that has a physical input that is a value between 0 and 1, like the trigger on a controller or the joysticks on a controller. Adding a dead zone means it has to surpass this number before it starts being registered. And that's because a lot of controllers will get a little sticky over time and start outputting values of like 0.05. And that can be really annoying if your character starts looking in one direction when you're just trying to stand still. So that's what dead zone is for. Upper threshold is the same thing if you wanted to max it out, if you wanted not to count it after a certain amount, which I couldn't think of a reason why you would want to do that, but at least it's there. There's also several ways to calculate a dead zone. So by default is smooth radial. That's what you'll want to use most of the time. There's also axial. Axial treats the X and Y axes separately, which would create a square of a dead zone. This usually isn't desirable because the corners require farther values than the tops and sides do. So smoothed radial normalizes that into a circle. There's also unscaled radial, and this uses simply a circular dead zone, nothing else. While smooth radial also uses a circular dead zone, but it smoothly scales the values as they leave the dead zone, which kind of gives a more gradual transition. I haven't done much testing between the two, but I believe this one is better for micro movements and a better feel overall. Okay, let's look at the next modifier, which is FOV scaling. So by default, I'm actually going to remove this, and I'm going to go into the player. Let's create a debug key. I'm going to make it 1, and I'm going to change our FOV with a flip-flop. So I'm going to do flip-flop. I'm going to get the camera. I'm going to set the field of view. So when I first press it, I'm going to make it really narrow, like 40. And when I press it again, I'm going to make it back to the default, which is 90. Now, if I play and I look around, and then I press 1 to make a much shallower depth of field than I look around, it feels much more sensitive. It's not technically, it's moving at the same rate, but just the way field of view works and our eyes work, it kind of feels like this one is more intense. I'm moving my mouse at the same little circular movement. You can see how much more intense it seems when I'm zoomed in. So if we add a modifier of FOV scaling, it will compensate for that difference, and it will make the movement feel the same at every FOV. So I'm going to do the same thing. I'm slightly moving my mouse in a circle. I zoom in, and look, it looks the exact same. So this is great if you have an FOV slider in your game and you want every FOV to feel like it's moving at the same rate. As far as I can tell, the FOV scale applies to every single scale, so it just kind of works like a scalar value. So if I do 2, it's twice as sensitive on both the outside and the inside. So I always just leave this at 1. FOV scaling type, there's either standard, which is using Unreal's current scaling method, and there's a legacy mode for Unreal Engine 4 backwards compatibility. This used an older and a slightly more outdated formula to do the FOV scaling. I don't exactly know exactly what it is, but I hear it's a bit incorrect compared to the standard. So people only really use that if they're trying to make something backwards compatible with a UE4 game. So I'm going to leave this modifier on, and let's look at the next modifier, which is negate. So a negate modifier just flips the sign of the input. If you were using a float, 0 to 1 becomes 0 to -1. Since we're using a vector 2D, we have 2 values, an x value and a y value. And if you remember, I multiplied the y value by -1 to get it feeling correctly. But instead of doing that, I could just plug in the y and then tell it to negate on the y-axis. And I'll uncheck x because I don't want x negated. Now we're not using z because it's a vector 2D and not a vector 3D, but I like to uncheck it anyway. And now I have the exact same result. And I like to do that because now if I use this, I look in other places like other players or just any other classes, I don't have to remember to multiply this by -1 every single time. So I'm going to leave that one. I'm going to leave that modifier on there as well. So the next modifier is response curve exponential. A response curve changes how an input value progresses from 0 to 1. So normally an input would increase linearly. So if you imagine somebody slowly pressing down on a controller trigger, it would, at the exact same rate, go from 0 to 1 normally. If you have the response exponential curve, it'll map that value to an exponential curve, so it'll start out slower and end up a lot faster. This could be useful for, I haven't tested this, so don't take my word for it, but maybe like pressing on a gas pedal or something could feel more correct with this kind of curve rather than linearly. You can also choose how much it affects each axis, the exact same way the negate modifier works as well. So x, y, and z, you can choose how much it affects those. Now, if you like that idea of the curve, but you don't want it to be exponential, there's also response curve user defined, in which you can create your own manual curve and apply it to the x, the y, and the z. But I'm just going to remove it. All right, next up is the scalar modifier. This just multiplies our input value, and you can do it by each axis individually. So let's say I want less sensitivity on my x and y. I'll just put it at 0.5, and now I'm moving half as slow. You can't really tell on camera. So let's try 0.1, and yeah, it's taking me a lot more movement to move the same amount. And you could make them different amounts if you'd like that. I'm going to leave mine at 0.5, just because I personally always seem to like a lower sensitivity, so that one's just for me. Okay, next up we have scale by delta time. So normally, moving something by a fixed amount every frame causes it to move at different speeds depending on the frame rate. For example, if we rotate our character by 1 degree every frame, then if our game was running at 60 frames per second, we would rotate 60 degrees within 1 second. But if our game was running at 30 frames per second, we would only rotate 30 degrees in 1 second. So to fix this imbalance between values, depending on what your FPS is at, you have to multiply it by the delta time, and the delta time is the time in between frames, how long it takes to go from one frame to the other. Of course, that's always a really small number, so when you scale by delta time, you also usually have to multiply by like a really high number to compensate for it now feeling very slow. But at least it will be the same on every frame rate. But if you're building an input action like for looking or moving, or anything that works with the player controller, control rotation, or the character movement system, that already has the delta time multiplication built in. So we don't actually want it on those. We'd be multiplying it by delta time twice, and that can create very weird issues. All right, next up is the smooth modifier. The smooth modifier is intended to smooth an input out over multiple frames instead of just using the raw value. However, I haven't been able to observe any noticeable difference when I use it. I hear this is because of the way it's implemented, and I haven't verified it myself, but I've heard that in the input code, the amount of frames they use to quote-unquote smooth is only 1, which means it gives you the exact same result as if you didn't have it. So maybe this is something they'll update in the future. The next one is smooth delta, and at the time of recording, smooth delta has very little, if not any, documentation. I've done a lot of research on it and really can't find anything, and I've done a lot of experimentation with it and also can't come to a clear result. You can choose a different smoothing method here, choose a different speed, and pretty much every time I try something else, I get different weird results. So I'm trying to look around and it's making me look right. If I change this to lerp, kind of freaks my camera out. So I'm not actually sure what you're supposed to be able to achieve with this. My best guess is it's supposed to be a different way of applying smooth where you have more control over the way it smooths out with all these options. But since smooth doesn't work, maybe that's why this one doesn't work either. All right, next is swizzle input axis values. This one lets you switch axes. So remember, if I move my mouse left and right, it maps that onto the x-axis, but we can swizzle them, and by the default here, it switches the y and the x. It now goes yxz instead of xyz, meaning moving my mouse left and right now moves my camera up and down, moving my camera up and down now moves me left and right. And you have every possible combination for switching two values. And the last modifier on here is to world space. Now, I'm actually going to save this one and talk about it a little bit later because it's going to make more sense once we add a little bit of movement code. So we're going to come back to this. I'm just going to delete it for now so it doesn't mess anything up. Now, here's something really cool. We can create our own input modifiers. So to create a custom modifier, right-click, go to Blueprint Class, search for Input Modifier, and select that. I'll call this User Settings Sensitivity. And what I do a lot for my games, I assume I'll have a settings menu with a mouse sensitivity slider. And once again, instead of having to remember to put all that code right here, like how much to multiply this by our sensitivity, I can just have it all happen inside of the input action. So you have to override the function modify raw, and that gives us three values. One is the player input class. This is the class that essentially handles input on the back end. And you can use it to access other inputs if you're doing something like a combo or a chorded action trigger like they had before. But we're not going to be using that, so we just want to pass that through. And we also have delta time, and we can just pass that through as well. And then we have the current value, which is a struct. If we break it, we get our x, y, and z values, and we also get the type. If I type a switch, you can see all the types, and it's just the bool axis 1D, axis 2D, axis 3D, if you need to use those. So we want to modify this input by our sensitivity setting. Now, I didn't set up a sensitivity setting for this project because it's just temporary, so we're just going to use a different one, pretend it's sensitivity. So if we get game user settings, and this is usually where I would get my custom mouse sensitivity settings, but that doesn't exist. So in place, I'm going to use get default resolution scale just because it outputs a float, and we're going to pretend that's our mouse sensitivity. Then we just want to multiply all three of these values. So I think the faster way to do that would be make a vector to combine all three, then multiply the vector by our resolution scale. And we have to make this struct pass through the type, split this vector, and plug in x, y, and z, and make sure the execution pins are hooked up. And immediately, if you go back to the input action, add a new modifier, you have that new option, user settings sensitivity. So I'll add one for user settings a lot. I'll add one for inverting the y-axis because some people prefer that. And anything that directly changes inputs, I'll put those into input modifiers rather than into my code where the input actions are called. Now, don't actually use this one because then your mouse sensitivity is going to be based on your resolution scale, and that would be really weird, but this was just for a demonstration. If you're trying to modify a bool input, since these are all floats, a bool input is just translated into an x value of 0 or 1. So that's how that's translated if you need to mess with booleans. So now let's create an input for moving as well. So I'll right click, go to input, input action, and I'll call this IA move. Open that. This one I also want it to be a vector 2D because we're moving on 2 axes, forward and back, left and right. And that's all we have to do in the input action. Then in the mapping context, I'll go ahead and add it, choose IA move, and this is the first time we don't just get a 2D axis thing to plug into it. We have to convert 4 keys, W, A, S, and D, which are all Boolean values, into one vector 2 value. And I'll cover this just real quick, but if you want to do a joystick, they do have that built in. So if you do gamepad, you can do left thumbstick 2D axis, and that works just like the mouse 2D axis, and that'll just work out of the box. But we don't want that. We are doing mouse and keyboard. So I'm going to I need to re-add it because I deleted it by accident. So if we were to say, make W a key for IA move, W outputs a Boolean, but this input action outputs a vector 2. Let's go back into our player. I'm going to move all this down, do IA move, add that in, and then I'll call add movement input. We need 2 of these because we move in 2 different directions. And the 2 directions are the forward direction, so I'll get the actor forward vector, and the right direction, get actor right vector. Plug those all in. Now the scale value will be the action value broken. Forward vector is the Y axis, forward and back, and X is left and right, so we'll plug that into scale. Now this works because the scale value will be 0 by default if we're not pressing anything, but if you imagine a joystick at the moment, if you press a joystick forward, that outputs 1 on the y-axis, and if you pull it backwards, it outputs -1 on the y-axis. So we would move forward if it's forward, and backwards if it's backwards. The exact same is with the x value. But we've just put in a single W key right here, which is a Boolean. So how is this going to work? If I hit play and I press W, I move right. And I move right because, like I explained before, when converting a Boolean, which is true or false, it converts into a value of 1 or 0. 1 is true, 0 is false. Now, when you have a vector, which is more than one float, in this case a vector 2, you've got 2 numbers. So when you convert a Boolean into a vector 2, it just injects it into the first number, which is the x value. And I meant to write y here, not x, xy. So pressing down on the D key gives us a value 1, and it puts that right in the x value, which outputs a vector 2 of 1, 0. So 1 on the x value is positive on the x value, which makes us move right. So let's go back into our mapping context and change that to the D key, because that will be our correct way to move right. Okay, so we got the D key working. How do we move left if we can move right? Well, let's make the A key, which is the key we want to be able to move left. Now, by default, this will also output a value of 1, 0, but we need it to be a value of -1, 0, or we don't even really have to worry about the y, we're only worried about the x here. So to get it to -1, we can actually add triggers and modifiers to specific keybinds rather than the entire input action themselves. If I open up look, and I open up one of them, you can see modifiers from input actions. You can see the ones that are applied to the entire input action, but you can also apply ones to specific keys. So for the A key specifically, I'm going to add a negate modifier. And it doesn't matter that these 2 are selected, but I'm going to unselect them because just to make it clear to myself, we are making the X value backwards. So I can press D to move right and S to move left now. Okay, so let's try our next one. Let's add a W, and this time we want to move forward, which would be a value of 0, 1 on the y-axis. So how do we convert our Boolean to the y-axis? We need to add a swizzle input axis values, because this switches 2 of our axes. We want our x to become y and our y to become x. And it's as simple as that. We can now move forward when we press W. And backwards, I'm going to give you a second to guess what we have to do for the S key. And if you didn't get it, it's swizzle or input axis values and then add a negate. And I'll just put this on the Y. And there we go. That's how we get our 4 input keys to be remapped to a single vector 2 input. Now, there's still one subtle issue here. I'm going to hit play, and I'm going to press A and D at the same time. What you would expect to happen is I would stay still, but I'm moving left. Now, I move left, but it feels like I should just stop if I'm holding both directions. Now, the reason this is happening is because we're using 2 different inputs to call the same input action. So it's asking, what does it do because it's getting two conflicting inputs. Well, by default, if we go to the input action and we open this advanced tab right here, we get accumulation behavior, and it's set to take highest absolute value. Now, what this actually decides is, for a long time, I thought that would always choose to go right because right is moving 1 and left is moving -1, but it actually seems that it chooses whichever is lower on your list. So we move left because A was assigned after D by holding both. But if I take this and I put A above D, now D is called second, which means we move right when holding both of them. But neither of those are desirable. We want to stay still. So instead of take highest absolute value, we want to switch this to cumulative, which instead adds the two inputs together rather than deciding which one has priority. And since one's -1, one's +1, we just stay still. Hold A and then D, D and then A, and we are all good. And now I want to revisit that last modifier, the world space modifier. So let's go back into IA move and add a modifier and add to world space, which is the one I skipped. It's just easier to understand in the context of moving rather than moving our camera. So right now we assume X is left and right, because if we imagine a graph, X is left and right, and Y is up and down. So naturally, that's how we assign our movement. But if we choose to world space, this is actually a bit of a misnomer. It should really be called to the relative space of the character that's calling this input, but I guess that was too long for them to type out. Because if we go into our player, we go into our viewport here, we can see if you look at the tiny little gizmo in the bottom left right here, our character faces X, so X is the character's forward and Y is the character's right. So if we have that modifier, our X values, so I'm going to press D, moves us forward, and our Y values moves us right. And it doesn't matter how we rotate, it's not technically world space. D always moves me forward because it's using my player's space. Now, I can see the reasoning behind maybe wanting to use it in that way, but just because I've been using it the other way for so long, it feels very weird to me, so I don't like to have it on. But that's what to world space does. Okay, let's go over the rest of the settings that we haven't talked about yet. So I'm going to go into the mapping context first, and we've only been looking at the default key mappings, but I'm going to skip down here to registration tracking mode. So right now it's set to untrack, which it means it does not count how many times we've added a mapping context. I'm going to duplicate this and add the exact same one twice. Everything should still work exactly the same. And immediately after, I will call remove mapping context, and I'll make sure it's our IMC input tutorial. And I hit play, and I can't do anything because I removed the context. Now, even though I added two of them, I only had to call one remove mapping context because it's not tracking the amount of times it's been added. If I change this to count registrations, now it's counting them, and it says, oh, we've added this twice, but we've only removed it once, so one will still be active. So I can still move around. Now, these don't like multiply against each other, so I don't really know why you would have this on, but it's good to know that it's there. I'm going to delete these two, so we're back to normal. Next is input filtering right here. Mapping context can be filtered based on input conditions. For example, you could restrict a context to only accept keyboard and mouse input, or you could restrict them to only have gamepad input or any platform-specific input. And by default, it uses the use project default query. This system compares every input to a tag, the tag being enhanced input.modes.default. If you go to edit project settings, enhanced input, and open up input modes, this is the tag it checks against. Now, I assume every single input that's built into this, if I just open this, like all of these have that tag applied because all of them work. So I don't really think this actually filters anything out. I'm not really sure what it does specifically. Maybe it filters out unknown peripherals, like some really wacky controllers. But you could also make your own by using a custom query and creating a new one. So just clicking this, writing a description for it, and then checking, oh, do the tags match this? Enhanced input modes default looks like that's the only tag, but you could probably assign new tags to different inputs. This is something I've never really bothered with. I figured if you want to separate the mouse and keyboard versus the gamepad, you could just make two mapping context. You can also select do not filter, which just doesn't filter anything. Next is mapping profile overrides, right here beneath default key mappings. If we add this, we can basically do what we've just been doing with default key mappings, but we can do it in a separate profile. So you can make a profile maybe for left-handed people, and these mappings could have separate controls somehow. You know, whatever you want to do. Or You could create one for southpaw configurations, everything like that. So if you had a settings menu where you could switch between predetermined setups, this is where you could set up the other ones. That saves you from having to duplicate entire contexts. You can store them all in one context if they're all supposed to do the same thing, just with different keys for different profiles. Okay, I'm going to go back to input actions, and let's talk about the rest of the settings here. So we have this checkbox right here, consume lower priority enhanced input mappings. If you have two mapping contexts that both use the same key, and one mapping context has higher priority than the other, this setting controls whether the higher priority action prevents the lower one from receiving input. So if it's checked, which it is by default, the higher priority input consumes the key and the lower priority one never fires that key. If you unchecked it, then both would fire this input action. I'll just turn that back on. Consume action and access mappings. This is for the old deprecated version of input. So if you go to edit project settings and go to engine input, this is the old-fashioned way of adding it. It's very outdated, but you could add input right here and make it whatever. And if you had actions here and they conflicted with the input actions we have made here, we could select this to ignore the ones we set in the project settings. Although you shouldn't really be using those anyway because they're very old and outdated. You can also set which trigger events will consume it. And once again, you can select as many of these as you want. Up here, we have reserve all mappings as a checkbox. So if you imagine two mapping contexts are active and both bind the same key, and the higher context mapping tries to use it, but it doesn't successfully trigger. You can imagine if it has the hold trigger and you release it before the second is up, this decides whether the input has been quote unquote used or not. So if it's unchecked and you cancel this, it will be passed down to the next mapping context, which will then consider if it's been triggered or not. Whereas if it is checked, even if we don't meet this threshold and the input is canceled, it won't get passed down. It's reserved only to the highest priority mapping context. Triggered when paused is pretty self-explanatory. It's whether it should trigger while the game is in its pause state. And I believe we have now covered every single option in these two, everything except player mappable key settings, but I'm going to save key bindings for a separate video since it's kind of its own can of worms. So lastly, let's go into the project settings one more time, find enhance input, and I'm going to talk about just a few of these as well. You can assign default mapping contexts right here. If you just select one and choose the default one. And with this, I don't actually have to assign it inside my player. If I go inside and disconnect it, even though I didn't add it, I can now still control myself because it's just added automatically. You can also do this per editor settings. So this is just for the project, but if you go one category lower, enhance input editor only, you could add one that will be applied to every single project that you make from now on. A powerful feature is the platform settings. This allows you to define different input setups depending on the platform your game is running on. So for example, Android and iOS would definitely have different input mapping contexts than a desktop game because they're totally different controls. So instead of coding in a bunch of stuff to which one to use based on which device, you can open this up, open up default, add a new input data, and we have to add a new one because none exist. So I'll just create this plus button, and yeah, I'll call it phone input data. And now that it's opened up, there's just one thing to change right here in class defaults, the mapping context redirects. We can add one. We could say IMC input tutorial, and this can be mapped to a separate mapping context, which we don't have any. So I'll just make a fake one, and I'll just call this phone map. And now we could say, if this one's used and you're on a phone, use this one instead. So it's really cool that you have that option to use different mapping contexts for different platforms. So send trigger events when input is flushed. So input flushing determines what happens when a game loses focus. For example, alt-tabbing out of a game or opening a system overlay or entering a pause menu, it flushes the input, which is saying that the keys that were held down are treated as now released. This is so if you were like holding W and then you hit pause while still holding W, your player could keep walking while the pause menu is open, and you wouldn't want that. It would consider that you release W before everything opens up. So what's important here is whether the inputs should trigger their completed or canceled events while they're being flushed. So it could count them as released, but unchecking this means it won't fire the completed or the canceled pins, while checking it checking it means it will right before your settings menu opens or you alt tab or something. Enable default mapping context needs to be checked if you want to use the default mapping contexts. And you can also set the default modifier and trigger values in here. It's important to note that this actually does, the default mapping contexts actually do not automatically apply in earlier versions of the engine. This is 5.8 where it does, but I think like 5.6 and before, it actually doesn't do this yet. And it was only for referencing in C++ to easily get parameters inside of this. So this one might not work for you depending on your input action, depending on your engine version. So that's about everything I can think of to cover enhanced input, except for player key rebinding, and I'll do a separate video for that. So please let me know if you have any questions. I've created a cheat sheet of all of this information on my website, geckogamedev.com, where you could also check out my course where we create a horror game from scratch, start to finish. I hope you learned something, and I'll see you next time.